Hello everyone, welcome to this video. In this video, let us see the solutions of Model Question Paper 1 of Basic Electronics and Communication subject. Let us go to the question paper. With a neat block diagram, explain the working of DC power supply. Also mention the principal components used in each block. Here, the question is on DC power supply. Means we need to write the block diagram of the DC power supply, what we have discussed in Module 1. So they have asked to write the principal components involved in each block. So we have four blocks here. First one is a transformer, then we have rectifier, then filter is required and a voltage regulator. So these blocks will be containing a transformer like this. So this rectifier will be containing any kind of a rectifier, half wave, full wave or a bridge rectifier. And smoothing filter requires a capacitor and a voltage regulator using a Zener diode or a BJT we can say. So this much is required with respect to the block diagram is concerned. With each and every blocks need to be explained in 2 to 3 lines of explanation. Why? Because the explanation for a question carries half of the marks. If the question is asking for 7 marks, block diagram will be for 3 or 4 marks. Since we will be having 2 block diagrams here, it may be given with 4 marks for the block diagram and the remaining marks will be there for explanation. These 2 block diagrams are not sufficient for get 7 marks. You need to write the according explanation. So the explanation required is explaining the 4 blocks in brief, not in detail. So let us move on to the next question. Mention advantages of negative feedback in amplifier circuits. With relevant equations and diagram, explain the concept of negative feedback. Here there are 2 questions here. One is the advantages of negative feedback. Another one is with equations and a diagram, explain the concept of negative feedback. There are 2 ways you can follow. First, you can write the advantages of a negative feedback like this, and then you can go with the block diagram or circuit with expressions and an explanation. Otherwise, first explain the negative feedback completely and derive the expression for overall gain, since they have asked you to write the equations also. Then come back and write the advantages. No worries. But here the advantages carries 2 to 3 marks and diagram and the expressions carries 2 to 3 marks, and explanation what you are going to give for the negative feedback means 180-degree phase shift will be occurred in the negative feedback. Feedback network will be producing 180-degree feedback. Phase shift, that is much required here. So the concept of negative feedback in the sense they will look for 180-degree phase shift by the feedback network, and input signal and the feedback output will be not in phase. They are going to take a phase shift. So these are the kind of answers you can underline also, so that you will be getting the maximum marks for the question. And then with a circuit diagram and waveform, show how operational amplifier can work as an comparator. So this question is a straightforward question on amplifier or operational amplifier. So this is an op-amp circuit. So for this we need to write the waveform. In the question they have asked to write the waveform also. So this is an input voltage V2. These two are going to be compared and output will be generated like this. How this comparator is going to behave, that you are going to write in the explanation. So here the marks is splitted as 2 plus 4. Totally it is 6. Then the next question is on bridge rectifier. Working of the bridge rectifier is asked in the question. In the question itself, they have asked you to write the circuit diagram. Even if they have not asked you to write the circuit diagram, means even if they have not mentioned in the question, you are supposed to write the circuit diagram for these kind of questions. Okay, in electronics subject, most of the questions will be having a circuit diagram or the kind of block diagram that you are supposed to be written before writing the explanation. So this circuit, and in rectifiers, remember you need to write how the circuit is going to behave when the positive half cycle of the input is applied and how the circuit is going to behave when the negative half cycle of the input is applied. That is also required. So you need to write these 2. That fetches you maximum marks. Okay, this diagram is sufficient, but if you write these 2, the examiner or the evaluator come to know that you will know the answer completely. Then he will give the full 8 marks for this question. And don't forget to write the waveform, and explanation will be this much of explanation is sufficient. If you write point wise which diode is on, which diode is off in this particular condition in the positive half cycle of the input and the negative half cycle of the input. That is sufficient. And then write a note on frequency response characteristics of an amplifier circuit, clearly mentioning the half power frequencies. Here they are asked to write the frequency response characteristics of an amplifier circuit. So here we don't know which is an amplifier. That's why it is better to write all the frequency responses like this for a different kind of amplifiers. And they are asked to mention the half power frequencies. Means the frequency response is going to be written like this with respect to the output power or the gain with taking frequency in x-axis, and half power frequency means what? This is the maximum gain we are going to get. We need to come down by 3 dB if we are going to represent this output power in dB. Suppose if they are not writing in dB, if we are writing in terms of power as it is the value, so we need to take half of the power. So we are going to get two values in this curve. We need to take down to reach the x-axis. This frequency will be called as F1, this frequency will be called as F2. So these frequencies they are asked to plot in this curve. That is what clearly mentioning the half power frequencies. And then we need to write the explanation in such a way that the frequency at those points where the 50% drop in the power or minus 3 dB we are going to take, then we will be having F1 and F2. Those will be called as half power frequencies. This is what the kind of answer they are expecting for this question. And the next question is on 3-stage ladder network oscillator. Means it is on RC phase shift oscillator, as you know. Okay, list and explain the condition for sustained oscillation. To get the sustained oscillation, what is the condition? Feedback must be positive and throughout the loop the phase shift should be 0 degree or 360 degree. Over loop voltage gain should be equal to 1, that is A into beta is equal to 1. These two are the conditions we need to satisfy in an oscillator circuit to get the sustained oscillation, correct? That is my first half of the question. The second half will be a problem. So 3-stage ladder network oscillator is concerned, we need to know the expression. So first we need to write the expression as F is equal to 1 divided by 2 pi root 6 into RC, and they have given it as 3-stage. If they have given it as 2-stage, the expression 2n, n is 2, 2 into 2 4, root 4 comes into picture if it is 2-stage. In your syllabus it is 3-stage ladder network oscillator given. That's why obviously the problem will be on 3-stage itself. Even if they have not given 3-stage, you take it as root 6, that is correct. And if you calculate by putting the values for this expression, you will be getting 647 Hertz. This problem I have solved in the problems video also, you can refer that. And the next question is discuss the design of 3-bit asynchronous up counter. You can see this is a question number 3. So we moving on to the second module. This is from here onwards, this is module 2. Okay, and 3-bit asynchronous up counter is the question. So using JK flip-flops, we are designing a up counter, that is asynchronous means we are not giving the common clock to all the flip-flops. We are giving the clock to the first flip-flop or the bistable, and output of that will be an input for the next one. This will be called as asynchronous. This line you need to write first. That is the good way of writing the answer. First you need to write what is asynchronous, what is 3-bit. 3-bit means it is starting counting from 000, it will go up to 111. This much you can write, and then writing a truth table and the explanation related to asynchronous counter, and then waveform. This much carries 6 marks. This is very important question for exam. And with a neat block diagram, how typical input and output blocks are connected to a microcontroller unit. For this block diagram is sufficient, and with this we will be having 2 more block diagrams we have discussed. That is not required since it is asked for 7 marks. If they are asking for 10 marks, ADC at the input side and DAC at the output side, that and all we can write with this block diagram. Here it is asking for 7 marks, this block diagram and explaining what are input ports, what are output ports. Here is the explanation I have given, and how the operation of microcontroller will be. The control program will be loaded into memory, and these are the output devices connected to a output port. these are the input devices. These things need to be explained in brief. If the block diagram or circuit diagram or expression is there in the answer, that carries maximum marks. Your explanation carries half of the marks. With the help of timing diagram, explain how D-type bistable works. D-type bistable works means directly the question is on working of a D bistable. So D bistable we have studied. You can write the block diagram. If you know the circuit, you can also write the circuit. But here they are not asking the gate level circuit to write. You can just write the block diagram like this. It is a D bistable converted from SR bistable, and truth table is must. First write the 1 or 2 lines of explanation what is D bistable, and then write the block diagram. Better to indicate the name of this block as D bistable like this, and then write a timing diagram, and then with respect to the truth table. Your timing diagram should match with the truth table. Here writing clock is equal to 0. Here also clock should start with 0. Maintain the answers like that. And then design full adder using 2 half adders and a OR gate. Here the question is on full adder, but we need to design that using 2 half adders. In this case, there might be a chance of writing wrong answer. By considering a full adder as a question, you just implement using basic gates. That is wrong. Here we need to implement or design full adder using 2 half adders. That's why better to write the half adder first and the truth table for that, and then gate level circuit for that. Using this half adder module, I am designing a full adder. Here is my 1 half adder. I am putting 1 more half adder, and this is the generation of sum, and this is generation of carry. Okay, this much you need to write. So truth table is necessary. First write the block diagram. Before that write the half adder, and then come to the truth table. Looking at the truth table, generate the sum as well as carry expression, and then a circuit diagram. This carries 8 marks. Design 4-bit shift register using JK bistable. Here the question is given as 4-stage shift register. 4 stage is same, and it can be given as 4-bit also. Both are same. 4-bit shift register need to be designed using JK bistables. You know this circuit, write the circuit. You can give whatever the data you want. In the textbook they have given it as 1010. You can take 1111 also. You can take 1010 or 0101 also, and tell us how actually the shifting will be. You need to write with respect to the clock signal. That's why write clock, and then whatever the input we are going to give serially one after the other, and then what is the output of Q3, Q2, Q1 and Q0. And a little bit of explanation is needed, since we have preset J, K, how the connections will be, whether it is synchronized or asynchronized. Since clock is given to all the flip-flops or the bistables like this, it is a synchronized clock. This will be called a synchronized circuit. You can write that also. And with respect to the shifting, you need to write the explanation. These two should be correlated. Then write a note on different data types, mentioning the bit size and range of value supported. Which are all the data types we have discussed? Bit, starting with bit in the sense it is a one binary number we can say, and then byte, it will be having 8 bits, word it is 16 bits, double word 32 bits. These are the different data types available with respect to the data is concerned. Data and those types, and a positive and negative number is also available, so you need to write that also. They may expect what is a positive number, what is signed number, what is unsigned number also, so you can write these with respect to the data types are concerned. Then explain the working and principal operation and application of a stepper motor. Here the question is on the working or the operation of a stepper motor. Okay, but better you write the circuit with respect to microcontroller is considered. Microcontroller diagram and interfacing with respect to the stepper motor is concerned. You just write this block diagram and explain how actually the motor is going to rotate. It will be having a permanent magnet in the center, and it will be having a coil. That coil will be loaded with the values like this, and these values can be given one after the other. If it is a full step, half step, you can explain, and little bit explanation with respect to the working. when we give this, what happens, like that. And they are asked to write the application also. Wherever stepper motor can be used in a 3D printing, textile machines, gaming machines and all, we can use stepper motor. Since this question is for 8 marks, I recommend you to write this block diagram also with the stepper motor table and this diagram and all. If they are asked to write the same explanation for 5 to 6 marks, no need to write this microcontroller implementation. Next, write a note on classification of embedded systems. Embedded system can be classified as based on the generation, based on the complexity, and little bit of explanation is required for each and every classifications. Okay, with respect to 8-bit, 16-bit controller processor can be used. Similarly, based on the complexity, small scale embedded system, medium scale as well as large scale. You need to write the explanation by writing these two. You can also write the in detail classification, but they are not expecting this. You just write the based on generation as well as complexity. For 6 marks, write two lines of explanation for first generation, second generation. You just give what is the bit size of a processor which can handle in first generation and give an example. Similarly for the second, third, fourth generation. Similarly for the small scale, medium scale as well as large scale. Then bring out the main features of UART and USB. UART and USB. First you need to write what is UART. It is a protocol. It will make the serial data communication, and then it will be having 2 wires, and you need to write this diagram. Here this is one UART, this is another UART. How the communication will be transmitted to receiver, receiver to transmitter, and this is the format, packet format. This much is required for UART for 3 marks. 6 marks will be divided as 3 plus 3. UART for 3 marks and USB for 3 marks. What you can write for 3 marks? One block diagram, a 2-3 lines of explanation, packet representation. And then coming to USB, again a block diagram, and you can write this table and a little bit of explanation how USB devices can be connected in a group. And then classification of transducers with examples. See, for this question, you can write output transducer, what is input transducer also. You can write active transducer, passive transducer also. Just they are asking to give the classification of transducers with examples. Means if it is output transducer, what is the example? Loudspeaker. If it is an input transducer, what is the example? Microphone. Likewise, you can write however the classification will be, but you need to give some examples. Remember the examples like output transducer is a loudspeaker, input transducer is a microphone. Similarly, for a passive and active transducers, you remember thermistor, strain gauge, LDR are the examples for passive transducers. Active transducer in the sense it is a photovoltaic cell and a piezoelectric crystal. Examples carries 2 to 3 marks, and other explanation what you give, that is the next half of the marks. Next, bring out the differences between RISC and CISC as well as Harvard and von Neumann. Again it is for 6 marks. So how the marks division will be? This is for 3, this is for 3. You need to write the differences. Only 3 or 4 differences are enough. You can remember the easy differences. If it is RISC, reduced instruction set computing, here the instruction set is reduced. Here the instruction set is complex. You can write the first difference easily. And it is software centric design, it is hardware centric design. Here, since it is a reduced instruction set, simple decoding the instruction is there. Here the decoding is complex. Likewise, you can remember 3 to 4. I recommend 5 differences in between RISC and CISC. Similarly, in between Harvard and von Neumann, you just remember 5 differences. This much is enough to get 3 to 4 marks for the difference if they ask. And then define actuator and briefly describe the following actuators. Which are all the actuators they are asking to describe? Relay and piezo buzzer. Here again it is for 8 marks. It is divided as 4 plus 4. Relay need to be explained and piezo buzzer need to be explained, and also we need to define the actuator. Means definition of the actuator carries 1 marks, and the remaining 7 marks will be divided as 4 plus 3 or 3 plus 4. So here a microcontroller diagram need to be written. Here also microcontroller connected with a buzzer need to be written. Obviously these block diagrams carries 2 marks. and extra only 1 mark and 1 mark or 2 marks for explanation. By looking at the marks, you can write the explanation what it is required. Describe the blocks of a basic communication system. Here in the communication block diagram, first it is a source and then a transducer and then a transmitter, then channel, receiver, output transducer and final destination. Here what the mistake you are going to do, there is an input transducer here, here is a transmitter. You just confused where actually the transmitter and transducer, you may chance of there may be an interchange also. Don't make such mistakes. If you do such mistakes, it will fetch you 0 marks. Okay, the block diagram should be neat and you need to write the names of those blocks clearly. Then only, even if there is small mistake in the explanation, it will be not considered. So write the block diagram here carefully. What is the first device? It is source and then transducer and then transmitter, channel, receiver, transducer and final destination. Here what are all the signals we have in between these two blocks? It is also can be shown here. Even if you are not showing this, it's okay, but you are going to write in the explanation. Okay, these signals here in the block diagram given for our understanding, but we need to show these blocks clearly and the arrow mark. These signals what we have written here can be written in the explanation also. No need to mention in the block diagram itself. That is your wish. Then define the following terms: modulation, carrier communication and baseband communication with suitable waveform. Here they are expecting the waveform, means if it is a carrier communication, we will be having a baseband signal, low frequency signal, we will be having a high frequency signal. Then we need to show the modulation also, right? If it is a baseband communication, we need to write only the message signal or the baseband signal, that is sufficient. So if we write this block diagram by showing a baseband signal and a modulated output, this makes the waveform for the carrier communication. For the baseband communication, no modulation is there. One line you need to write it as there is no modulation. We are going to send the baseband signal as it is. Then explain the following with the help of waveforms. Here PAM, PWM, PPM and PCM are asked for just 8 marks. Each carries 2 marks. So waveform is sufficient. You need to write one message signal, one carrier, and then these 4 waveforms are sufficient. For PCM, we will be having a sampling and quantization block diagram. You can write that fetching the maximum marks. And define sampling theorem and explain when aliasing can happen. Also mention the different ways to mitigate that. Means aliasing can be avoided. Means here we need to write the statements exactly that carries 1 or 2 marks, and a simple expression is there. There is a condition that Fs should be greater than or equal to 2 F maximum. This should be written, and these two will be supporting that particular expression. And with respect to the aliasing is concerned, when it is occurred, when it is avoided, we need to write it separately and we need to underline, then we will be fetching the maximum marks. Okay, and little bit of explanation is required. With that, when it is avoided means a low pass filter or the anti-aliasing filter need to be used, and also the sampling frequencies should be Fs is greater than 2 F max. This much is required here. And the next question is explain the following terms: multipath, constructive and destructive interference, coherence time, coherent bandwidth, delay speed. Here 1, 2, 3, 4, 5, 6 concepts are there. We need to define those. Define in the sense, just we need to write what is multipath, what is constructive interference, what is destructive interference. Here I have given just the definition, not in detail explanation. So just the definition, that supporting block diagram is required. It is not must. If you write this block diagram, it fetches you the maximum marks. You just write the definitions as it is. Delay spread. Then define antenna and discuss different types of antennas. Here again you can see the marks allocated for this question. It is 4 very less. We can define the antenna. We can write antenna is a device which is converting electromagnetic radiation into electrical current and conductors, or vice versa, depending on whether it is used in receiver or transmitter. This is the definition. This definition carries 1 or 2 marks. In 4 marks question, it carries only 1 mark. Then they are asking to discuss different types of antennas again. So there are 5 to 6 antennas are there. We need to just write the type of antenna, and we can write one line of explanation for this. So since it is 4 marks, 1 marks is gone for definition, another 3 marks. Even if you just list out the antennas, 5 to 6 antennas, they will give marks. So to avoid the explanation, what we need to do, we need to write the architecture or the block diagram with respect to those antennas. Then draw the schematic diagram of a cellular telephone system and define its basic components. In a cellular telephone system, we will be having a connected telephone, means wired telephone, and then PSTN, MSC, and then base station BS, and the mobile station finally. This is also indicating a car, it is also a mobile phone. Okay, here we need to write uplink and downlink. What is this and what is base station, what is MSC, what is PSTN, what is this telephone. This much carries 6 marks. This block diagram carries 2 to 3 marks, and explanation carries the remaining marks. Here we need to write 3 lines or 4 lines of explanation for each block. Then explain the optical fiber communication system with block diagram. Again, here a block diagram is there. In between this, you can observe this block diagram is same as the communication block diagram what we have seen, modern communication. But after the information and the transmitter, here we will be having optical source, and here in between we will be having optical fibers, like that. So you can relate these two and you can read, and here showing the optical fiber is very important in this diagram, and diagram carries 3 marks. And what is transmitter, what is the information we can send, what do you mean by optical fiber, and how the communication will be, total internal reflection. These are the things we need to write here as a explanation. Then with the help of diagrams, discuss the following types of network topologies. Ad hoc network topology and infrastructure network topology is asked in the question. This carries 2 plus 2, 4 marks for the diagram itself, since the question is for 8 marks. And the explanation related to what is ad hoc network, how the communication will be, and what is infrastructure network topology, how the communication will be. That carries another 4 marks. This gives you complete 8 marks. Then 10th question, with the help of architecture figures, explain evaluation from GSM to LTE. We will be having a block diagram of evaluation system from GSM to LTE. We need to write this. You can write, since it is asked for 8 marks, you can write the block diagram or the architecture of GSM also while explaining, and also LTE, 1G, 2G, 3G, and those explanation will be supporting the answer for this question. Then list the requirements identified for the 4G technology. What are all the requirements identified for 4G technology need to be written. Here there are 6 requirements. 6 requirements need to be written. A small explanation is required. High spectral efficiency, reduced cost per bit. These need to be explained briefly. Okay, since it is only asked for 4 marks, listing out these is sufficient for 4 marks. But one line of explanation is better for getting full marks. And then draw the block diagram showing the basic elements of a satellite communication system. This is a satellite communication system. Here it is asked for 8 marks, means you need to explain what is user, what is terrestrial system, what is earth. Here again a transmitting antenna, what is uplink and downlink, and then receiving antenna. Again the same things here. This need to be explained briefly so that the explanation carries 5 marks. Since this block diagram is not much complex, so the weightage will be less for this. Okay, you can see some block diagrams will be having a circuitry. Those circuitry will be a complex circuitry, means for the diagram they will give more marks. Even if you write the less explanation, that is okay. But if the block diagram is simple like this, you need to explain the blocks neatly, in detail you can say. So here the explanation carries maximum marks and the block diagram carries less marks. This is how you can answer the questions in your examination, and this is a sample paper. You can expect few questions from this also, since many of the important questions are asked here. In the next video, let us see one more question paper, that is model question paper 2, so that we will be getting the maximum information how actually the answers will be. Thank you.